Hey, in this video, we're going to talk about ASP.NET Core, and we will be building an API project with Entity Framework Code First approach as our database communication. If you want to know more about the theoretical aspect of ASP.NET Core, like what it is and how it is different from the previous version of ASP.NET and .NET Framework, and what are the advantages and what are the disadvantages of ASP.NET Core, so I have a separate video for that, and you might find the link of that video in the description. But this video is going to be nerdy, the total code, and we're going to see how practically we can create a new API project with Entity Framework Code First. So let's get started. So when we talk about creating a new .NET Core API project, we have two options. Either you can use Visual Studio or you can use the command line in order to do that. We're going to look at both. So creating a new API project with Visual Studio is fairly easy. All you need to do is you need to just type in Visual Studio, open up Visual Studio. And then over here, there's an option, create a new project. Just click on that. And from the project templates, there's ASP.NET Core Web Application. So just hit next and then give it a name. So we're not using that option, so just give it any name, maybe test API. And you can select your default location where it's going to keep all the files, and then you can also select the solution name, and then you can select this option, place the solution and project in the same directory, and hit next. This is where the actual type of project comes in. So either you can create an empty ASP.NET Core project, or you can create an API. So when you create an API, so it does have a default API controller called weather forecast, and it has some get and post method. Or you can create a web application which is going to be based on ASP.NET Core engine, and it's going to have the Razor pages as front end. Or you can create a web application which is going to be a model view control application. So it will have some API control with the RESTful get and post methods, and also it's going to have some front end with ASP.NET MVC views. Or you can create a single page application. So if you create this, it will have a front end as Angular and the back end as ASP.NET Core. And if you select this, it will have front end as React.js and back end as ASP.NET Core. But we are not using the Visual Studio way of creating a new project. In fact, we are using the command line to create a new project because there's more freedom of creating the project using the command line. So in order to do that, just go to a location of your choice where you will create all the projects. In my case, I'll go to D drive, and in the work directory, this is where I create all my projects. So I'll create a new folder and I'll call it Employees API. That's what I'm going to create. So just open it up. Now just select this path and type in cmd. What it's going to do is it's going to open up the command line with this location selected as default. And now in order to check which version of ASP.NET Core you're using, so the command is .NET --version. So see, we have ASP.NET Core installed, and we have version 5.0.104. And now in order to create a new project, first of all, I will tell you exactly how we can find out all the commands that are being used in ASP.NET Core. So that is it. When you do that, .NET help, it gives you all the command that you can have. Either you can add a package, or you can build a project, or you can list all the references. But what we want to do is we want to create a new project. In order to do that, we need to use this new command. So the command will be now .NET new. When we do that, it gives us a list of all the options that we can have. Either we can create a empty web application, or a model view controller, all the options that we saw before in the Visual Studio interface. But as we know that we are creating an API project, so in order to create an API project, the option is API. So I will type .NET new API. Now it's building all the files, and see, it has created a project, and all the required files are here. So what we want to do now is that we want to open that project in Visual Studio. In order to do that, you need to double click on this employee API.cs proj file, which is the project file of this .NET Core API project. And by double clicking on that, it's going to open this project up in Visual Studio. And on the right hand side, you see a list of all the files and folder that were included in this project. So in order to run this application, before getting into the details of all the files and folders and important files, I want to run this application. I want to see exactly how it looks. Just click on this IS Express button, which is going to use IS Express to run this application in the browser. And as you can see that this API opens up the Swagger UI for this API. Interesting, right? I'm not going to talk about what Swagger is and how it is used and what is this interface. I'm presuming that as an API developers, you guys already know what Swagger is. Just to let you guys know that in this latest version of ASP.NET Core, Swagger is added as a built-in support. As you remember, in previous version, we used to add this Swagger functionality as Nuget package, but the good thing that about the latest version of ASP.NET Core is that it's added as built-in support. So right now you see that in this employees API, we have a weather forecast endpoint. It says get weather forecast. When you click on that and click on try it out button and click on execute, you see you gets a JSON with a list of some weather forecasts about some of the locations. And now we're going to get into the project again, and let's going to stop it. And let's talk about some of the very important files that are added in this package. The very first thing I want to talk about are the configuration files. One of the biggest advantage of this .NET Core framework is that now it is using the JSON-based configuration. As you remember, in the previous version of ASP.NET, in the .NET framework, we had XML-based configuration like web config files. But now you know that JSON is becoming more popular as the mode of communication between application. So .NET Core has decided to use JSON files as configurations. So one of the very important JSON file configuration file is launchsetting.json. It's in the properties folder, and this launchsetting.json file contains all the configuration related to the launch setting of this application. For example, if you're going to run this application using IES, what is going to be the URL and what is going to be the port that it's going to run this application? And secondly, what is going to be the environment, whether it's the development environment or the production environment. And this is going to be the default URL. It's going to be appended with the URL. It means that whenever you run it, you want the Swagger UI to be the default view of this API. And one more thing that is very important, that either you can run this application IS Express, or there's a built-in server called Web Listener. You can also run or launch this application using the Web Listener. We're going to talk about that later, but just to let you guys know that when you run it using the Web Listener, it is going to listen to the port 5000. And we're going to see that later on, how you're going to run it. So this was the launchsetting.json file. Another very important configuration file is appsettings.json. This is where you store all the configurations related to your project, whether they are the database configuration, whether they are the session related configurations, or whether they are the client secrets or API secrets or API keys. So all that information goes here in the appsettings.json. And there's a very bigger advantage of using .NET Core is that if you remember in the previous version of the ASP.NET framework, we had the web config file. And when we were going to deploy that web application on some environments, we used to change these configuration values for each environment. But it's not the case here. .NET Core allows you to have individual app settings JSON files for each environment. For example, we have appsetting.development.json. So when you're running on the development environment, it is taking all the configurations from this appsetting.development.json file. And if you have other environments like a QA environment or a test environment, you need to have other environment related configuration file like appsettings.qa.json and appsettings.test.json, and you need to pull all the environment related configurations on those configuration files. But if you have any configuration that are common for all the environment, you need to keep those in appsettings.json file. The next file I want to talk about is the startup.cs file. We call it the backbone of ASP.NET Core application. This is what makes the ASP.NET Core application a .NET Core application. And this is a starting point of ASP.NET Core application. And within that startup file, we have two very important methods called configure service and configure. We're going to talk about each of those. The configure services is a method where you define all the internal dependencies and services that are you going to use in throughout your application. For example, what database you're going to use, whether it's the Oracle database or SQL Server. So this is where you define it. And if you are going to use the Swagger UI, so this is where you are going to define the dependencies. Similarly, other dependencies, for example, the repository dependencies and all the interfaces, you define all the dependencies here. And it accepts the iService configuration.services file. So if you have other dependencies, you define those using the services object. The configure method, on the other hand, is used to define all the middleware for your HTTP request pipeline. You know that it's a API project, so there's definitely an HTTP request pipeline. So all the middleware that you define for your HTTP request pipeline are defined here. And one thing to note here is that order of the middlewares that you define here is very important. So you can't have this defined before that and this defined before that. So you need to be 100% sure of which middleware are you putting first and which middleware are you putting later on. And another important file that I want to talk about is the program.cs file. A lot of the developers, when they see this program.cs file for the first time, they really get confused because, as you know, program.cs file is a part of console application normally. So they say, hey, why do we have this program.cs file in a .NET Core application, which is a web application? So just to let you guys know that ASP.NET Core web application is in fact a console application. So when the program starts, the very first thing it executes is the main function, just like it would in any console application. In the main function, it creates a host where it will host the .NET Core API. And in order to build that host, it uses the startup.cs file, the one that I just described earlier. So one thing that you guys need to know that this startup.cs file is just a convention. You can have any other file with any other name. You just need to reference that startup file here. So if you have like my startup.cs file with configure and configure services method, you can reference here, and ASP.NET Core will start from your own custom built startup file. Now, as you know that in the initial part, we ran this application and I showed you that it has a Swagger UI with a weather forecast controller. So with a weather forecast API endpoint. So this is where this weather forecast endpoint executed. We have a weather forecast API controller, and within that controller, we have an HTTP GET endpoint. And it is using this weather forecast model. It's returning IEnumerable of weather forecast, which is right here. So we don't want to do that. We have our own employee related endpoint that we want to introduce here. So in order to do that, we need to develop this model. Delete it and delete this weather forecast as well. Right. We deleted the weather forecast controller and weather forecast model because we want to have employees controller and employees model, and we want to return this information from database instead of hard coding it. Now, if you want your .NET Core application to communicate with the database, for example, SQL Server, we would like to use Entity Framework Code First approach. Now, I'm not going to talk about what is Entity Framework and what is Code First approach and what is Database First approach. I'm presuming that you guys have this information already. But if you don't, and if you want to learn more about entity framework, code first, and other approaches, I have a separate lecture for that, and you might find the link for that lecture in the description. So, in order to have your application communicated with the database, or using entity framework code first approach, there are certain packages that you want to add in your project. And in order to add packages in your application, you might want to open up manage Nuget packages. So this is where you can search all the packages that you want to install in your application. So in order to use the entity framework code first approach, the very first package that you want to add is entity framework core. When you would search it in the tab, you would find this, and this is exactly what we want to add. Now I'm seeing an uninstall option because I have this package already installed in this application. So you would see install option and you need to click on that and it will install the latest version of Entity Framework Core in your application. The next thing you want to install is Entity Framework Core SQL. And this is the package that you need to install. And still, I'm seeing the uninstall button because I have it installed already. You need to install the latest version of this package. The next thing we want to have is the tools. Since we're using the code first approach, so we would like our models to be converted into our database schema. And in order to do that, you need this package. You need to install the latest version of this package. And the last thing I want to add is the design. I'll talk about later on what it is used for, but as of now, you just need to install the latest version of this package as well. Once you have all these 4 packages installed in your application is ready to use Entity Framework Code First to communicate with the database. So in order to do that, the very first thing we need is the Entity Framework DB context, which is a wrapper that communicates with the database, the underlying database. So I normally prefer to add the DB context in a folder called data if you're adding the Entity Framework code in the same project. In a real-world application, we normally have a class library and all the entity framework code and classes, they go into that class library, and then we add the reference of that class library in the main project. But we're not going to do that. We're going to have the entity framework code in the same application. So I'm going to add a class, and I'm going to call it employees DB context. Now we need to add the libraries that we had recently added. I'll say using Microsoft.Entity Framework Core, then using Microsoft.Entity Framework Core.SQL Server. Now we need to inherit this employee DB context with DB context, which is a built-in class of an Entity Framework Core. Now we need to add constructor, and we need to have the options, which are DB context option, and we need to have the strongly typed options of employees DB context. We call them options, and we need to call the base class constructor, and we need to pass the option. So it means the options that are going to pass here, entity framework is going to call the constructor of this parent class with those options. The next thing we want is a model. I normally prefer to add all the models in the model folder if you are to keep the models in the same project. So the model that I want to add is the employees model. Let us call that employee. And in the employee class, we want to have following properties. The very first thing we have is an ID that is going to be the primary key of the table that entity framework is going to generate in the underlying database. Next thing we want is a name, which is going to be first name plus last name. So we want to have a single field for that. And the last thing we want is an email. That's all. That's all what we want to have in our employee. Now let's go back to our DB context class, and we need to add a DB set. And I'll call it employee. And in order to do that, we need to add these models in the context class. So I'll say using, now we want to add the employee model and we call them employees. It's called pluralization if you want to have your table name as pluralized. So you can call it employees, but it's your choice. You can have anything you want. In fact, I want to do that in a property, get and set. So now I think we are all set. The next thing we want is the connection string in our appsetting.json file. Remember I told you in the beginning that if you want to have some settings with respect to the current environment only, you can put those settings in the environment related configuration file. But if you want to have some settings that you want to to be common for all the environments, you need to put those settings in the appsetting.json file. So I'm going to do that. I'm going to put my connection string in appsettings.json file. So in order to do that, I'll call it connection strings. And within the connection string, let's have the default. I call it default connection. So this is going to be the name of that connection string. Now I'll use my local SQL Server Express to be used as underlying database. So this is the name of my server. So it's going to be like this: server equal this, and semicolon, then database, or I think it's database equals, you can call it any database, employees DB, then since it's connection equals true. I think we're good. One thing you guys need to make sure that this term connection string, it has to be in the camel casing. So C has to be in the uppercase and S has to be uppercase S, because this is how .NET Core recognizes it as connection string. Next thing we want is that we want to add the employees DB context as service in our configure service method. Remember, we talked about configure services method in the beginning, that this is where we define all the internal dependencies and service that are going to be used throughout our application. So as you know that we're going to use entity framework code first throughout our application as database communication. So we need to add this dependency right here. So in order to do that, what you need to do is that services.add context, add DB context, and it has to be strongly typed, and it has to be employees DB context. Remember, this is the class that we have, and now it's going to let me add, or I think, yeah, API.data. This is the format, and then use SQL Server. It has to be used SQL Server, but in order to do that, you need to add the libraries that we had added initially in our project. So it's going to be Microsoft.EntityFramework.Core and Microsoft.EntityFramework.Core.SQL Server. Now it says use SC. Now it's available. Now within that use SQL Server method, we need to pass the connection string. So in order to access any configuration from our configuration file, we have a dependency added in our startup class, that is iConfiguration. So we already have a configuration object through which you can access any configuration from your appsettings.json files. So in order to access the connection string, I'll say configuration.getConnectionString. And within those braces, we need to pass the name of the connection string that we want. The name of our connection string is default connection. That's it. This is how you define the connection string service in your configure services method. Now, as you know that we are using the code first approach, and in the code first approach, you don't actually create the database and the database table. ASP.NET Core creates the database table and the schema by itself. This is the server that we are going to use, and as you can see right now, there's no database called employees DB. And that is exactly what we are going to do. We're going to use the code first approach to create the database and all the tables. We want a database that has the name of that database should be employees DB, and there should be one table in it called employees. An employee table should have an ID, a name, and an email, just like we defined earlier. So in order to do that, what we have here in .NET Core, a tool called migrations. Migrations are used to generate the underlying database schema that reflect your models. So in order to use migrations to generate your database and your database tables, all you need to do is you need to open the command line tool. I prefer using command line tool to run the migrations. There are other ways too, but the command line is the most convenient way. Now you need to type in cmd, and the command to run migrations is .NET EF migrations add. I'll explain everything, and let's call it initial create, and let's just run it. When you run this .NET EF migrations add init create, it doesn't actually run the migrations. It doesn't actually create the database or create a base table. It simply creates a file that it is going to use later on to generate the database. We're going to look at that later on, but very first thing we want to do is that we want to see that right now we have a migrations folder, and within the migration folder we have two files, initial create and the snapshot. Let's talk about this init create.cs file first. This init create.cs file has two methods, up and down, and they're both taking the migration builder object. So this file is used when .NET Core is going to run migrations to create the table in the database. So as you can see that it is going to create a table called employees, and within the employees, it has three columns, ID, name, and email. The name and email, they're going to have nvarchar max as the data type, which you can change right here. And the ID is going to be an integer with the identity with the seed one and increment one. And there's going to be a constraint that the ID column of this primary key, this table is going to be the primary key. And then there's a down method when you're going to delete this. So it is going to use the down method to delete the employees table from the database. So this was the init create file. Then we have a snapshot file. This snapshot file contains the current state of the database. It means that right now the database, it has a model builder object and it has a build model method. So in this build model, it says that right now it has one table, and this table has three columns. So I'm going to tell you the difference between this init create file and the snapshot file. For example, later on, you're going to have another model called maybe student.cs or person.cs or the salary.cs or order.cs. So when you're going to run the migration, so in the migration, you will have individual file for each of the table, just like this file. So you're going to have another file for order table, one more file for student table, and one more file for the audit table. And each of those files will have an up method and a down method with migration builder. But there's going to be just one snapshot object. And in that snapshot, you will have a state of all 4 or 5 tables of that database. So every time you add a new table or add a new model in your entity framework, the snapshot file is going to be updated. And this is what entity framework is going to use to have the information about the current state of your database. So I think we're all good to go right now. As you can see that in our database server, in the databases, we don't have an employees DB, and that is exactly what we're going to do. In order to run the migration, remember we don't have this migration ran already. We're going to do that right now. So in order to do that, just open up the root folder of this project and open up the command line and run .NET EF migrations .NET EF database update. Remember, initially we typed in .NET EF migrations add. This actually adds a migration file in the Solution Explorer, but it doesn't actually run it. In order to run the migration, you have to type in this command, which is .NET EF database update. Just hit it, and let's just wait for what it does. It first of all builds the project. Now the build is successful, and now Entity Framework has actually done running the migration in the database. So in the database server, you're going to refresh the databases, and you see now we have an employees database. If you open it up and see the tables, right now we have the employees table right here. So if you just select it, right now we don't have any record in that table. So I'm just going to insert some records into that. Insert into employees, and it's going to be name and email. And the values are going to be, I'm going to add in my own name, which is Sir Faraz. And my email is going to be zagam.sirfaraz@gmail.com. And we can add another record, maybe any name of, maybe Donald Trump. So it's going to be d.t@gmail.com. So just add it, and right now we have 2 records in our table. The other table I want to talk about is the EF migrations history, dbu_EF migration history. This is the table that contains the information about the history of all the migration that you have run so far on your database through Entity Framework. So if you see the records of the table, it says that right now there's only one initial create ran, and it ran on this time 2021-06-02, and this is the time, and the version the version of the product is 5.0.06. This is actually the .NET Core version. What I'm going to do is that just for the demo, I will create another model, and I'll call it test model. I call it test model, and within that I would like to have ID, and I'll say string test field. That's it. And in our context class, I'm going to add test, and I call it tests, right? It's just the testing. And now in order to create the database, in order to create the table in the database, all you need to do is you need to run the same commands again. So it's going to be .NET EF migrations add, I'll say, second table. So what it's going to do is that it's going to create another file called secondtable.cs. Let's do that. It's going to build first. See, we have another table called second table, and it has the model builder for this new table. And as you can see that now the snapshot file has been updated. Now it contains the information about the second table as well. And in order to apply those updates in the database, the physical database, all you need to do is you need to type in this command, .NET EF database update. When you press enter, you're going to have these changes reflected in the database. So just refresh the tables, and now we have another table, which is an empty table. We're not going to use that in our project, but just in order to show you how it. See, now we have a second table, and the version of .NET Core is 5.0.6. So just to let you guys know, the EF migration history table contains the history of all the migration that you had run on your database so far. Now, the next thing we want to do is that we want to add an endpoint in our controller. So right now we have a model. We need to add a controller that is going to contain our endpoints that are going to expose data from our database. So just click on Add Controller, and make sure you don't add the MVC controller. You just need to add the API controller, because our project is an API that has some endpoints. So just click on API and empty API control, click on Add, and then you're going to have a default name called Values Controller. We don't want that. We want to have our controller name as Employees Controller. Just click on Add. So when you add it, By default, it has a root annotation says API/controller, which means that our endpoint is going to be our API URL slash API slash employees for this particular employees controller. But we don't want that. We want to remove this API word from our endpoint. So we just need to remove this API endpoint from our root annotation. So now our endpoint URL is going to be our application URL slash employees. And then we can have the methods of our own. Now, the next thing we want to do is that we want to access our entity framework from our controllers and in our endpoint. So in order to do that, first of all, we need to define an endpoint, which is going to be public action result, and it's going to be get, or maybe call them get employees. And I'll say return okay. So it's default, and within that okay we are going to return a result. But in order to get the employees data from our database, we want to access our employees data context. Now, it's not a good idea to access the context from the controller because we want to implement the separation of concern. So in order to do that, what we want to have is a repository that talks to the context object and that returns the data from the database to the controllers. That is exactly what we're going to do. So what you need to do is you need to add a folder, and we call that repositories. So this is a layer that is going to communicate with your entity framework data context, and data context is then going to communicate with your database. So first of all, we need to add a repository, and it's not going to be a class, it's going to be an interface. So if you do the new item and get interface, we call this interface as I employees repository. Now this is an interface. Let's declare it as public interface, and within that interface we want to have two methods. So the very first method we want to have is public list of employee, I think it's employees, and get employees, and it gets nothing. And the next method we want to have is public int insert employee, and it takes employee object employee object as emp. And now we're going to add this model. Yep, it's employee. So we're going to have two methods in our repository, get employees and insert employee. Now we are going to define the concrete class for this iEmployees repository. So we can define here, it's called employee repository. And we want to implement the iEmployee repository, and then we want to implement the interface. So we're going to have two interfaces. So in order to access the context object, remember that in the startup file we have defined this context object. So by default, this context class is injectable. It means that you can inject this context class in any of your class where you actually need it, and .NET Core is going to give this class an initialized object of the context class, and that is exactly what we're going to do now. We want to inject the context object in this employees repository so that we can access the data from the database through the context object. So in order to inject dependencies in any class, all you need to do is you need to first of all define the constructor. So there's a shortcut for that, cdor and tat. It's going to add a constructor to that. Next we want is employees db context, and it's going to be underscore context. We want to have this option of and now we need to initialize a new field, which is going to be a private field, private employees db context, and it's going to be context And over here, we need to initialize this context with the one that is injected into this class. And I'm going to explain it to you. So whenever .NET sees that in any class in the constructor, if there is an option of employees DB context, which is an injectable class, so .NET Core is going to provide an initialized object of context to this class. And what we're doing is in the constructor, we are initializing our own private employees DB context object with this object that .NET Core provides to us. So this context object can be used throughout this class in order to communicate with the database. And that is exactly what we're going to do. Instead of throwing an exception in this method, we're going to do is return context.employees dot. I don't think that we have the employees. Oh, I'm sorry. I did not set public to that class. It has to be public. Otherwise, we won't be able to access it. And now context.employees.toList. And similarly, over here, what we can do is context.employees.add emp, which is what we are getting from the upper layer. And then we can return context.savechanges. So if any of the rows are affected through this insert statement, it's going to return the count. And that is exactly what we are returning through method. Now, we want to access this repository concrete class in our employees controller in order to access the methods, but we can't directly do that. We have to make this class as an injectable. And in order to make any class injectable and injecting the dependencies in .NET Core, you need to define it right here. So in order to define dependencies that are you going to use throughout your application, here are the lines of code that you're going to write. Dot add scoped. So we have two options. Either you can add a singleton dependency or a transient dependency or a scope dependency. I'm not going to talk about those, but just to let you know that if you're going to add a scope dependency, it's going to be valid for the current request. So first of all, you need to define the interface, which is going to be employees repository, and then employees repository. So first of all, let's just add, I think we are misspelling it, employees repository. So this is how you define the scoped dependency. First of all, you uh, put in the interface name and then the concrete object name. And now wherever you would define it in the constructor, .NET is going to provide that class an initialized object of this employees repository. Now go back to our controller and remember how we inject dependencies in any class. First of all, define the controller with the CTOR, and then within the controller we need to have employee repository underscore repo. So we need to add the namespace that is required. And now we're going to initialize our own private repository object with the one that we get from the .NET Core. So first of all, we need to define our own private employee repository, and we call it repo. And now we're going to initialize this repo with the one that we received from, yeah, there you go. And now we need to redefine our get employees endpoint. And in order to have an endpoint, we need to define the verbs for an endpoint, whether it's HTTP GET endpoint or a POST endpoint. For HTTP GET endpoints, we need to define this annotation right here, HTTP GET. And instead of returning an empty OK, now we're going to return repo.getEmployees. So let me rephrase it. The user, the caller of this API, calls this employees controller and this get employees endpoint. Our endpoint calls the repos get employees method, and then in our repos get employees method, we use the employees data context to get that data from our database. And now the other method we want to define is insert employees. So that endpoint is going to be an HTTP post endpoint, and we need to call this public action result insert employee, and within that we need to pass an employee object, employee, and we need to add the namespace, and it's going to be MP, and return OK of, or we call it repo dot insert employee, and we need to add. So I think our both endpoints are ready. Now we are going to test our API on our Swagger UI. So in order to do that, just run this application through IS Express. It's going to open up the Swagger UI in the browser. So there we go. Here comes the magic. We have a schema, employee, and it has ID, name, and email, and we have two endpoints. One is the HTTP GET endpoint, and the other one is POST. Now we're going to test the GET first. Just click on employees and hit try it out, and click on execute. See, we have two employees that we had recently added manually in the database, and the Zygum Sarfaraz and the Donald Trump. Now we're going to test our post endpoint, and in order to test it, just click on try it out, and just remove the ID because we don't need the ID, and the name would be maybe just say it any name, maybe Michael Rowan, which was my manager, and then the email is Mikel, it's not a real email, at email.com. Now click on execute. See, it's returns 1. It means that one row has been affected in the database. Now if you're going to test your get employees endpoint again, click on, oh, where is our endpoint? Yeah, this one. So we see now 3 employees added in our database. So this was very simple. In this video, we have seen how we can create a new .NET Core API, how we can add entity framework code first approach in our API, how we can use migrations to convert our models into the database, and then how we can use the Swagger UI to test our endpoints. In the next video, we're going to talk about the security of our API, how we can secure our API, and we're also going to learn how to use Xcode to test our endpoints and other layers of our API. Thanks. Keep watching my video and please subscribe to my channel.